Hello and welcome back to another episode of Math with So. Today we're going to be solving some systems of quadratic and linear equations. And the first thing that we need to realize is that a solution to the system is always where the graph intersects. So where these 2 points are the solutions to the system. And it is not just an x value, it is a y value. It is the coordinate points of both of these. All right. So in this case we have 2 solutions. And this first solution up here is at 0, 1, 2, 3. So 0, 3 is the first solution. 0, 3. And then the next solution is at -4, -1. All right. Versus number 2, where you notice that they do not intersect each other, this would be a no solution situation because they don't intersect each other. Whereas the third problem only intersects this one time, and that is at 2, 1 as the solution set there. Okay? So you get your answers by just looking at the graphs, but in some of these situations, you're not going to be able to graph them because they're, you notice, sideways parabola. But you should anticipate at least one, but probably more than one solution. Sometimes you'll end up even with 4 solutions, and that's the annoying part here. Okay, so in most of these situations, substitution method is going to be the best. However, elimination method is possible in some unique situations, and I would recommend using that if it's possible. So here, notice how x is equal to y plus 1, and x is over here as well. So that means that you can substitute this in for that x, and that means that we would have 2y squared plus 3y plus 1 is equal to y plus 1. And then you just have a normal quadratic problem that you would probably solve by factoring. So I'm going to move this y over, and I'm going to move this 1 over. And if I do that, if I subtract y and I subtract 1, I end up with 2y squared plus 2y because I'm going to subtract y and subtract 1. And then the 1's cancel, so this would equal 0. From here, always look for your greatest common factor, and in this case it's 2y, and you're left with a y plus 1 is equal to 0, which means that when we set our factors equal to 0, 2y equals 0, and y plus 1 equal to 0, you end up with y equals 0 and y equals -1. But that is not the answer. That is just the y values of the 2 solutions that we have. Okay, so now you get to pick whatever equation you have to want to plug it into, and I'm going to choose the bottom one because it looks a lot easier. So here I'm going to get x is equal to 0 plus 1. So when I plugged in 0 for y, I'm going to get a 1 for x. So when I got 1 for x, that was when y was equal to 0. Then I'm going to plug in the -1 for y. X would equal -1 plus 1, which is 0. So here, this is the x value. So 0 for x was when the y value was -1. So be careful when you're actually doing these to not flip-flop the x and y values. Okay? Believe it or not, that one is kind of an easier one because most of these involve some tedious foiling or something like this, like we're going to have for number 2. So see how here, again, this is what x is equal to. We can substitute that in for the x right here. But the problem is that x is squared. So we really have y plus 5 squared plus y squared is equal to 25. Okay? And by the way, this is a circle. X squared plus y squared is equal to 25 is a circle. So what we're really having here is like a circle with a line running through it. We have to FOIL the y plus 5. So this is going to be y plus 5 times y plus 5 plus the y squared is equal to 25. And then from here, we have to FOIL it. So this is going to be y squared plus 5y from this like double distribution, and then 5y again, and then 25. Plus y squared is equal to 25. Combine like terms. We got y squared, that makes 2y squared. We got 5y, that makes 10y plus 25 is equal to 25. Luckily, when we subtract the 25 to set it equal to 0, these cancel. So we are left with 2y squared plus 10y is equal to 0. Factor out the 2y, and you're left with y plus 5 is equal to 0. So we get our two values for y. Y would equal 0 from the 2y part, and y would equal negative 5 from the other one. And again, those are just the y values. We still need the x values. So when we have y equals 0, if we plug in 0 plus 5, x would equal 5. 0 plus 5. So that would be a point at 5, 0. And then when it's negative 5, if I plug in negative 5 plus 5 is 0. So when I get negative 5, x is equal to 0, and that would be 0, negative 5. Okay? Moving right along to number 3. Number 3, it is a problem where you may want to consider using the elimination method, because if you look here, x squareds cancel. They would go away. And that's very convenient. But notice how the negative x and the positive 5x doesn't cancel. And the 3y and the y don't cancel either. However, if you wanted to, you have two options. I am going to use elimination. We can't eliminate the x's and the x squareds, but we could eliminate the y's. We also are allowed to, see how this is what y is? We could substitute it in, but we haven't done an elimination yet. So if we wanted to eliminate, you would multiply the bottom equation by negative 3, because that would make this y negative 3y. And if we do that, we have to distribute everything. So we would end up with, I'm rewriting the top equation, negative x squared minus x minus 6 is equal to 3y. Just rewrote the top equation. Now I'm distributing. Negative 3 times negative x squared is 3x squared. Negative 3 times negative 5 is negative 15x. Negative 3 times negative 6, positive 18. Negative 3 times y, negative 3y. Add straight down. The y's will eliminate. So this is 0 equals, and then negative 6 and 18 is positive 12. Negative 1x and negative 16x is negative 16. I think I already said negative 16x. Negative 1 and negative 15 make negative 16. And then 1 and 3 make 4x squared. Okay? Now, these all do divide by 4, so if you want to factor out that 4, that will make your life a lot easier. And then from here, you're really only factoring this part, which is a simpler factoring problem. But if you had the 4x squared minus 16x plus 12, it would still be factorable. What multiplies to 3 but adds to negative 4? That would be negative 3 and negative 1. And this 4 can hang out here. It is not a solution factor because it doesn't have an x. So this 4 equals 0. It doesn't make a solution. But this one, the x minus 3 equals 0, you get 3 for x. And here, the x minus 1 equals 0, you get 1 for x. So we got our two x values. We need to find the y values. Now, the sad part is that the y values are going to be a little bit harder to find because you got to plug it in for x squared and x. But I'm going to start with a 3. It would be negative, in parentheses, positive 3 squared plus 5 times 3 minus 6 is equal to y, which would again end up being negative 9 plus 15 because you do 3 squared, then have the negative 1. 5 times 3 and then minus 6 equals y. That would mean that we end up with a y value of, I believe, 0. Okay, so when we plugged in 3, we got 0 for y. And now we have to plug in 1. So that's going to be negative 1 squared, not negative 1 squared, but negative and then the 1 squared, plus 5 times 1 minus 6 is equal to y. That equals negative 1 plus 5 minus 6 is equal to y. And that makes positive negative 2 is equal to y. So when we plugged in the x value of 1, we got the y value of negative 2. And these are our solution sets. Just one more for you. This last one, you probably are going to use, again, a substitution because x squared is equal to y. I can plug that in for this y right here. All right? So that means that we are going to have x squared is equal to x minus 3 in parentheses squared. Okay? From here, you got a few options. Technically, you could square root, but I highly suggest you avoid square rooting things like this because you may eliminate an answer when you square root. It's kind of like if you're not technically ever supposed to divide by x because you eliminate an answer. If you square root, there's a chance that you're eliminating an answer. What we're supposed to do is FOIL the x minus 3. So that's going to be x minus 3 and then x minus 3. And then you FOIL it out, and you get x squared is equal to x squared minus 3x plus 9 from this double distribution or FOILing. The x squareds cancel, so you do end up getting just a negative 6x and a positive 9. And we solve for x here. We're going to subtract 9 over. That'd be negative 9 is equal to negative 6x. And that means that x would equal 9 over 6, or x is equal to 3 over 2. Okay? I'm going to cross off the 9 over 6 because I don't want you to think it's another answer. So x is equal to 3 over 2. Then we have to find the y value. Well, we can plug it into the bottom equation. That would be a little bit easier. Y would equal a 3 over 2 squared, which means that y is equal to 9 over 4. You square the top, you square the bottom. So we write our answer as a coordinate point, 3 over 2, 9 over 4. There is our answer. And that would be the same thing as if we were to just square root it from that original part where I said be careful. Now, to show you what this graph would look like, because I feel like it's important, we got a vertex form of y is equal to x minus 3. So that would be to the right by 3. And then we have y is equal to x squared for the other parabola. One is facing up, and then another is facing up. And they only cross this one time, apparently, right there. All right? So that's going to do it for this one. Until next time, everybody, stay positive, and I will see y'all later. Bye.